Hi, I'm Luna from Google, and so yes, today we will talk about knowledge fusion and knowledge-based trust. The title and the content is a little different from the title and abstract in the course announcement, but the overlap is big. So this is collaboration with my colleagues at Google, including Van, Evgeny, Wilco, Camilo, Kevin, Xiaohua, and Wei. So I started working on the quality of data, especially quality of integrated data since 2007. And the major work is to figure out whether something is correct and whether the source is of good quality and whether some source copies data from some other sources and so on. So since then, I was collecting various examples from the web, so to give my talks. And I have a whole lot of examples about incorrect data, imprecise data, about out-of-date data, about ahead-of-date data. So this is kind of obituary before it really happens. And about how rumors spread out from Wikipedia, from tweets, from blogs, and so on. So I won't go to the details of any of this example, but today I'm going to give you my own example. So it started in February this year. I uploaded a paper which I was submitting to VLDB. I uploaded it to archive, and the title is Knowledge-Based Trust, Estimating the Trustworthiness of Web Sources. And that's kind of the major thing I will talk about in this talk. And then on February 28th, there was an article from New Scientist about our paper. And most of the stuff in the article is correct. So for example, the first sentence says, the trustworthiness of a web page might help it rise up Google's ranking if the search giant starts to measure quality by facts, not just the links. However, the headline of the news is very misleading. It is saying Google wants to rank websites based on facts, not links. And right after that, there have been a lot of news articles from at least 200 newspapers, or some of them being possibly blogs. And I'm sort of plotting the distribution of the articles over time. You can see that the peak is in the first week. And then there are news even until like when I checked it last weekend. And there are basically two voices. One voice is, there is a lot of misinformation on the web, and I really hope somebody would tell me what is true, what is false. And another kind of voice is, no, I cannot trust this knowledge-based trust. How can a machine tell me what is true and what is the false, and what is the role of Google on this? And this will definitely slow down the development of science, so on and so forth. And so the best way to tell you what's happening is to read some quotes from 3 Washington Post articles. And the first one is on March 2nd with the title, Google has developed a technology to tell whether facts on the internet are true. And it basically said, concluded that it's unclear exactly what Google plans to do with this new technology, if anything at all. Still, even the possibility of a search engine that evaluates truth is a pretty incredible breakthrough. And it definitely gives new meaning to the phrase, let me Google that for you. So this is very positive at this point. And then 1 week later, so on March 11th, there was a second article by another journalist titled, The Huge Implications of Google's Idea to Rank Sites Based on Their Accuracy. And at this point, he was describing what has happened in the previous week. And he said, Google's new research didn't explicitly mention how this approach might rank science contrarian websites. But media have been reporting this week that climate change skeptics seem unnerved by the direction that Google appears to be heading. If this ever moves closer to a reality, then they should be. And after that, one day later, the same journalist wrote another article saying why some people are so terrified by the idea of a Google truth machine. And he started with, there seems to be a fair amount of confusion and some critical points that I think people are missing. In a sense, Google is both closer to and farther from doing this than people seem to realize. Later on, he gave a lot of good analysis, good discussions. And finally, he said, it's a really exciting and a brave new world where big data and smart engineers can indeed, in theory, build tools and apps to help protect us from misinformation. What remains up in the air right now is precisely how and if these will be implemented, which is something I will describe in this talk. But back to my example, why do I say this is a data quality example? And so we see that I'm using a wide arrow from this first article to the rest of the articles, and a thin arrow from the paper to the articles. And although there are some articles very seriously, like quoting our sentences in the paper, showing our experimental results, but there are a lot of articles basically repeating what the first article says, especially repeating what the headline says. And there are a lot of information that surprised me. For example, one news article said, well, they are going to use New York Times and Wall Street Journal as their gold standard. And I mean, obviously, this is worrisome. And I couldn't remember where I mentioned at all these two newspapers. OK, so now coming back to this knowledge-based trust. And the motivation is that we want to provide a new perspective to evaluate web source quality. And currently, we evaluate the quality of the web pages, web sources, using link-based signals such as PageRank, I'm sure everybody knows, using search log and click-through rate, and also through some web spam detection. All of these are exogenous signals. But what we want to do is we want to evaluate the trustworthiness of sources by the correctness of its factual information. In other words, we want to use some endogenous signals. So what do I mean by the correctness of the factual information? So if we have a web page and we find out it claims 10 facts, and out of it, 7 are correct and 3 are wrong, then we compute the accuracy as the number of correct facts out of the number of all facts. And in this example, it is 7 out of 10 is 0.7. Right, wrong means whether it is consistent with the real world. So before I even talk about how to do this, let's see why we care about this. So here, one of the motivation is that the tail sources on the web, typically they are not well linked and they may not be viewed a lot, but they can be useful. Let me use Google Web Answers as an example. So Web Answers, basically, they look at the top returned answers for a question, and then they extract the answer from those snippets. And here, if you ask who played the Stumble is an award-winning guitar music. And then it will show you somebody shows how to play the Dumble stops in Freddie King's The Stumble. So it gives you the answer. This works well. However, if you ask about a not so popular song, like who played guitar going home, you didn't get the answer. It's not that this piece of information is not on the web. It is just not in the top returned results, top returned pages. So for example, this website called backingtrackguitar.com, it gives very precise information about the guitar players and so on. But its page rank is quite low because it's one of the tail sources. And on the other hand, we found that a lot of popular websites, they may not really be trustworthy. And here I'm showing 15 gossip websites listed by this URL. We found that 14 out of these 15 have a page rank among the top 15% of the websites. So why? Because we all love gossip. And can the trustworthiness of the sources help here? So in our system, we compute this knowledge-based trust, abbreviated as KBT. The value is between 0 and 1. As I mentioned, it's the percentage of correct facts out of all facts. And we can compute it for 5.6 millions of websites and about 120 millions of web pages. Here, I'm showing the distribution of KBT for websites where we believe we have at least 100 facts. And we see that the peak is 0.8 and 0.85. And more than half of the sources have a score over 0.8. However, there are also sources with low scores. This distribution kind of make sense because a lot of the websites give decent content, factual content. So how does that compare with the page rank? And these plotting where the x-axis is KBT and the y-axis is the page rank show that they are pretty much orthogonal. And there are a lot of some data sources between these two lines. They got correlated scores. But on the other hand, there are a lot of sources where the KBT is fairly high, but the page rank is low, especially in this area. So these are often the tail sources with high trustworthy contents. And I'm showing 4 examples here. This salary.com gives very good information about companies and colleges. This website gives very good information about UK livestock. This is what we just saw, the backing track guitar. And this gives very good information about Korean drama. It's not that it's not that many people care about Korean drama, but still a lot of people, like my mom, cares about it. And they can benefit from such websites if she can read English. And we sampled 100 websites where the KBT is above 0.9. And we found we are very confident that 85 of them are indeed trustworthy. For the rest of the 15, I will mention them later on. So on the other side, we also have sources where the page rank is high, but KBT is fairly low. And now let's come back to the gossip websites. We found that all of them have a knowledge-based trust in bottom 50%, meaning we believe at least half of the websites have a higher score than them. And we also find out that some forum websites have lower scores. So for example, like this web page from Yahoo Answers. I cannot tell if this is correct. However, they mentioned Catherine Zeta is from New Zealand, and from Wikipedia and some other data sources, we know that she's from Wales. And the third usage of this is that we can recommend websites by verticals, by domains. And this is because we can compute the trustworthiness at different granularities, at the web source granularity or at the web page granularity, or at web source granularity for every domain, for every vertical. So for example, if I search for food cheese, then it returns me something like wikipedia.org, CheeseWiki, Ranker, this is Cheese Platist, the Cheese Tick, etc. And it tells me about the accuracy of the information, the kind of the coverage of the information, etc. And instead, if I search computer, it will return me Wikipedia in different languages. It will return me open source software directory. This is free code, something like Linux links, so on and so forth. Okay, so at this point, any question? Okay. I hope now you are already curious about how we compute this knowledge-based trust. And recall that I said we want to find out the facts claimed by each web page and the correctness of each fact. And both of these tasks are very hard. However, we have a project called Knowledge Vault, where we try to build a probabilistic knowledge base. We use the 16 extractors, extracting knowledge triples, subject, predicate, object triples, from the whole web, including 2.5 billions of URLs and 28 millions of websites. And we extract from free text, from DOM trees, from web tables, and from annotations according to, for example, schema.org. After that, we put all of the extractions together and try to decide what is correct and what is not. And we generate a probability for each triple indicating its probability of being true. And then we build a probabilistic knowledge base. So coming back to our plan, now instead of looking at the facts, we want to look at all of the extracted triples. And instead of looking at true or false, we want to look at the predicted probabilities. And then we compute an average of the probabilities as the accuracy of the web source. So it seems life is good for now. But there is one important thing that is missing here. So does anybody find out something missing?
Relevance?
That's a good point. Not the major thing.
Well, is that accuracy that the extracted triple is actually an assertion of a fact or that it's a true fact? Because those are sort of distinct things.
I think you are getting there. So these are all of the extracted triples, and the probabilities are talking about the probability for the triple to be true, to be consistent with the real world. Yeah. However,
I'm finding out that consistent with the real world is often not true.
Yeah, everybody lies.
So for that part, we are hoping we have some magic way to find it out. But before even talking about that, we actually find out a lot of the triples are wrong because of some extraction errors. And so there might be triples wrongly extracted, not really claimed by the website. And this happens not only happens, but happens a lot. So for example, here we extract the triple Obama nationality Kenya from 2,000 web pages. And some of them are correctly extracted. For example, this one says, Michelle Obama declares Obama is Kenyan and America is mean. And some of them, however, are wrongly extracted. Like this news headline says, US will respect winner of Kenyan election, Obama says. It actually says the opposite. Obama is not a Kenyan citizen. And even for some correct, presumably correct triples, like Obama nationality USA, we extracted 2,500 times, and a lot of them are correctly extracted, but still some of them are wrongly extracted. So if you look at this screenshot, it is a blog by Tim Stanley, who is a historian of the United States. And the blog is talking about Barack Obama's life story contains myth, not truth, blah, blah, blah. But it doesn't say anything regarding his nationality or place of birth, etc. And this United States is about Tim Stanley rather than about Barack Obama. So this is wrongly extracted. So we randomly sampled 25 false triples, and we found that 11 of them have some triple identification errors. For example, they take part of the album name as the album artist, and 11 of them have some entity linkage errors. For example, they take Obama's father as Barack Obama. And 5 of them have some predicate linkage errors, such as date of birth and place of birth are wrongly matched. And only 1 of them have some source data error. In other words, the extraction errors actually dominate. And so we do not want to blame a source for those wrong extractions. So we want to identify the extraction errors. So there are some other challenges. The second challenge is that since we are going to compute the average of the probability is better to be well calibrated. So what do I mean by well calibrated? If for a triple, I predict its probability of being true is 0.7, then we hope its real probability of being true is also 0.7. In other words, if I plot the predicted probability and the real probability, it should be a diagonal line from 0, 0 to 1, 1. And what do I mean by real probability for one fact? So actually what we do is we look at all of the facts in the bucket with probability 0.7, and we look at their accuracy. The accuracy can be considered as the real probability. And if for the buckets of triples where we predict a probability of 0.7, 70% of them are correct, then the real probability for those triples to be true is indeed 70%. Make sense? Yes?
Where's your standard of correctness? Is this an external structured database or is this manual? Anything?
I will tell you soon. That's a good question. And the third challenge is basically how to handle two large sources or two small sources. And on the web, the data sources are very different. And this is a distribution of the number of triples extracted from each URL. We see that for 74% of the URLs, there are at most 5 extracted triples. And we don't have enough triples for trustworthiness evaluation. We don't have the statistical power. And on the other hand, there are some large URLs where we have more than 50K triples, a lot of them actually wrongly extracted. And they become the bottleneck in the parallelization in computation. So our solution is to use a graphical model such that we can predict at the same time what is the extraction correctness, what's the triple correctness, what is the accuracy of the web source, and what is the precision recall of the extractor. And here we use unsupervised learning or semi-supervised learning when we predict the correctness. So when we try to decide whether a fact or extracted triple is correct, we will leverage agreement from different sources, and we will give more trust to sources with a higher trustworthy or higher accuracy. And on the other hand, when we try to decide if an extraction is correct, we will leverage the agreement between the extractors, and we will give higher trust to the extractors with higher quality. And another thing is since we have super big and super small sources and extractors, we break down the large sources so they wouldn't be the computation bottleneck. And we merge the small sources such that they could borrow some statistical power from their neighbors. Now let's see some high-level intuition through some examples. Oops. So let's see we have 3 data sources providing the affiliation information for 5 database researchers. And let's say source 1 provides all of the correct affiliations, and source 2 and source 3 make some mistakes here and there. So if we do voting where we trust the majority, we can actually do pretty well. For 4 out of 5 researchers, we get the correct value, the red. And for Mike Cray, we have 3 sources giving 3 different affiliations, so there is a tie and we don't know which one is correct. Now if we look at the red marks, it seems source 1 is more accurate, more trustworthy than source 2 and source 3. So we want to give it a higher trust, a higher vote, let's say. And then we can correctly decide that UCI is the correct affiliation for Mike Cray. So we see that there is kind of a chicken and egg problem. Higher trustworthiness makes us believe that what it provides is more likely to be true. And more truthful facts make us believe that this is more trustworthy. So now let's come to extractions. And let's see, we have 3 extractors extracting Harry Potter actor, actress from one web page. And extractor 1 extracts 4 of them, extractor 2 extracts 2 of them, and the extractor 3 extracts these 3. And yes, question?
So the extractors today follow pretty much the same algorithms, but perhaps with different parameters, or do you have different approaches for each?
So they could use very different algorithms. They could learn different patterns. They could apply different models and so on. So we do not assume any detail. Yeah. Okay, so now again, let's do a voting. And then it seems these 3 are more likely to be correct, and these 2 are more likely to be wrong. And according to this, it seems extractor 1 extracts all of the correct things, so has a higher recall. Extractor 2, all of its extractions are correct, so it has a higher precision. And the extractor 3 has medium precision recall. And then now, if we look at the extractions again, Daniel and Rupert are extracted by high precision extractors, so it is more likely to be true. And on the other hand, Eric is missed by a high recall extractor, so it is more likely to be wrong. Make sense? Good. So this is what our graphical model looks like. We have 4 boxes. The W box represents a web source. The E box represents an extractor. The D box presents a data item, the attribute of some particular entity or subject-predicate pair. And then the V box represents a value for a data item. So in other words, the object in a triple. And these are our variables. X is our observation. EWDV means that extractor E extracts from source W the data item D value V pair. And CWDV means that web source W indeed provides the DV pair. And this is a latent variable. And VD shows that what is the correct value for this data item. This is, again, a latent variable. AW is the accuracy of the web source. It's a parameter. And PERE are the precision recall of an extractor. So note that this is basically the knowledge-based trust. And what we do is recall that this is chicken and egg problem, and certainly we want to do it in an EM fashion. And we first compute the probability of a web source provides a particular triple conditioned on the extractor quality. This is more of predicting the extraction correctness. After that, we compute the probability of a triple conditioned on source quality, and this is more of a prediction on the triple correctness. And then we compute the source accuracy, and we compute the extractor precision and recall. So these are by Bayesian analysis. They can be considered as the E step, and these 2 can be considered as M step. However, to simplify it and make it scalable to the web data, we simplified it a lot. And one way to consider this is for web source, we basically add some weight using the extraction correctness. And instead of computing the average of the triple correctness, we compute the average weighted by the extraction correctness. So far, so good? Okay, so coming back to our examples, we see that for this triple, we compute for this particular correct extraction, we compute a probability of nearly 0.8. And for this wrong extraction, we compute a probability of 0.13 regarding the extraction correctness. For the whole triple, we decide that the probability for the triple to be correct is 0 because it does not have enough support. And if we go to this presumably correct triple, then for the correct extraction, again, we compute a very high extraction correctness. And for wrong extraction, we compute a low probability. And for the triple itself, we compute a probability of 1. And this is mainly because of the high contrast between the two triples. And if we look at the distribution, we see that for those of the extractions where we compute a high probability for the extraction to be correct, the number of web sources providing USA is almost a half more than the number of web pages that claim Kenya. So recall that we want our computed triple probability to be well calibrated, and this is our calibration curve. And we see that although this is kind of a semi-supervised learning, but still here it is aligned very well with this diagonal line. Also on these two sides, it is very well aligned. And actually, the majority of the triples fall in these two areas. Here it is not very well, but on the other hand, it does not contain that many triples. And this is about triple correctness, and this shows the extraction correctness. So for some of the triples, we identify that it has some type problem. For example, claiming somebody's place of birth being, let's say, a company, which is obviously wrong. And for those things, they are definitely wrong extractions, and presumably, ideally, we should compute a very low probability for the extraction to be correct, and that is this red line. So for 85% of the triples, we compute a probability of 0 for the extraction to be correct. On the other hand, for the triples in freebase, which presumably are correct, we found that for half of them, we compute a probability of over 0.7 for the extraction correctness. Note that even correct triples can be wrongly extracted. So for some others, we compute low probabilities. And finally, this is the PR curve and the ROC curve of our predictions on the triple correctness. Again, they are in kind of a good shape. Okay, any questions so far? Yes?
Can you consider any models where the trust that variable A is a distribution over topics, so that, like a website could be more trustworthy on certain...
Yes, yeah. So that's a very good question. And actually, instead of looking at the whole website, we do look at a website predicate pair. Unless if there are only a few triples for a particular predicate, then we merge all such small predicates together. Mm-hmm. Yes?
So where did you get the model that has the constraints like somebody has to be born in a country, not a company?
So we basically have some, in the schema, in the knowledge-based schema, we have some constraints about if the predicate is place of birth, then the object should be location. Yeah. Any other questions? Okay, so the last question I would like to discuss about in this talk is whether we are really ready to use knowledge-based trust. And from the question, you possibly sensed that the answer is not that positive. And this might be a little bit disappointing if you believe you feel the results are interesting and the techniques are interesting. However, this actually shows a lot of good research opportunities. So let's start talk about it in 3 aspects. input readiness, the readiness of technology, and the readiness of output application. So let's start with input. So we recall that we used 16 extractors to extract knowledge triples. And even so, the extraction is very low quality. So on the one hand, the extraction is very sparse. For 74% of the knowledge of the URLs, we have at most 5 triples. And so we don't have enough information to say this is trustworthy or not. And in fact, we compute reliable KBT only for less than 20% of the websites and for far less than 5% of the web pages. And on the other hand, the extraction is not only sparse, but of very low quality. I really hate to say what is the accuracy of the extraction, but it already shows up here. It is as low as 11.5%, meaning if I extract 10 triples, then 9 of them are wrong. So I mean, so the expectation is likely to be like a garbage in, garbage out. Although we work very, very hard, but still we might miss some wrongly extracted triples, still predict them as correct. As a result, for those web sources, we will compute a relatively lower accuracy, trustworthiness for them. And another problem is that we have an imbalance between the extraction on free text and extraction on DOM trees. DOM trees have some structure, can be considered as semi-structured data, and there we have a better extraction quality. And for free text, we have lower quality. And among the 100 sample sources, with KBT over 0.9, 95% of them are mainly semi-structured data.
You can extract what the web page said correctly, or that the web page lied, and you extracted the correct line.
That's a good question. And here, actually, when I say the accuracy is 11.5%, it means among all of the extractions, among all of the extracted triples, 11.5% of the triples are considered to, are really true, consistent with the real world. And for the wrong triples, yes, some of them are indeed provided by some bad sources. However, recall that I said we did our sampling on 25 wrong triples, and 24 of them are because of extraction errors. Yes.
How do you validate accuracy? Do you do that like manually, or do you do that use another algorithm?
Yeah, that's a good question. So it's about how we evaluate the accuracy. We take the freebase as our gold standard. However, freebase only tells us what is true. It doesn't tell us what is wrong. And we apply a local closed word assumption, meaning if freebase have some information about Barack Obama's children, and then for whatever not in freebase, we will consider them as wrong in our gold standard, because we assume once it has some information about data item, about entity attribute, it has complete information. So that's local closed word. However, if freebase doesn't say anything about Obama's children, then whatever we see, we say no. We don't know if it is correct or not. Yes?
I'm still slightly confused on the difference you're describing to truth versus accuracy.
So truth is basically saying whether, given a triple, subject, predicate, object, whether it is correct or not. Correct,
That's my problem. Truth to me means it's makes absolute sense in the physical world. And accuracy is your triples reflecting what you want them to reflect.
want them to reflect. So you're saying that,
Your algorithm is working. But that's a precision thing, that's an accuracy thing. Truth means that it's true in the world physically.
So,
Like you can get lots of accurate triples with creationism or global warming.
yes.
Well, and that's going to be, that'll fit your algorithm just fine. None of that's true. You know, it has to be true to be consistent.
Yeah, so I guess there are two parts of it. And one part of it is whether this is already kind of decided to be true or false, and whether we have, I mean, in the physical world, we already know it is true or false. Not that everything is as simple as saying somebody's nationality being something. And in that case, like the global warming thing, I mean, it is fuzzy, and we basically sort of leverage the agreement between the sources and leverage, and we trust the authoritative sources more than other sources. So we make our decisions on both of them. On the other hand, we also have this kind of simple fact and sophisticated facts. And for example, coming back to the news headline, when I say when it says Google is going to use facts, not links, to rank the websites, it is false. But if it doesn't say not facts, then I mean whether it is true or false, it is not clear. So for those sophisticated facts, we even do not have a way to sort of represent it using the knowledge triples. And finally, basically here I'm saying factual information. I'm not saying anything about predictions or anything about the opinions and so on. Does that answer your question?
Partially.
Okay. Any other question? Yes.
So maybe narrowing down the domain a little bit so that you can increase the accuracy.
In terms of if our goal is to extract correct triples, then it would be good to narrow down the domains. However, if our goal is to evaluate the quality of a web source, we should look at whatever facts the web source claims.
Yes, but what I'm thinking is that, so first of all, in reality, a statement could be true under different models assumptions. For example, if you have certain things that assume that human beings are rational, then you have theorems that will be true under those assumptions. And then you follow a different model, like behavior, economics, and so on. And you find that people do a lot of irrational things. They both could be true under the specific interpretation. And then there are things that change according to the context. For example, it's raining now. This statement could be true at one place, but false in a different place. The truth value could vary from time to time. And then there are things about taste and so on. So all those, it seems that if you narrow it down to a particular context or domain, then you could have more precise meaning of whether it's accurate or not. Otherwise, both statements could be true, but with different interpretations.
So very good question. So there are basically two parts. Let me first say about the second part. An example is it is raining now. It is not true in general for the whole world, but if we say it is raining now in Palo Alto, at the Stanford area, then it is possibly true or false. And in that case, we actually make sure that in our knowledge triple, it is very specific. So for example, when we say this is the height of somebody, we wouldn't say just 163. We will say 163 centimeter or some 5 foot, etc. And for your first statement, like some of the statements is based on some assumptions. With these assumptions, this is correct, but with some other assumptions, this is incorrect. This is very interesting research topic, and we currently work on finding out different perspectives, because the perspectives basically are based on some assumptions. For example, if you consider the liberal view and the conservative view in politics, I mean, it also has some assumptions associated with it. It's hard to say if it is true or false, but associated with some assumption, then we can roughly say, yeah, it possibly is true or false with this assumption. Yes?
How do you deal with provenance, where one site is really derived from another site? For example, there are many sites which scrape the Wall Street Journal or Wikipedia. How do you keep from that both of them look equally correct, but you would register those as two confirming sources when they really aren't?
This is an excellent question. Basically, what if the one data source scrape data from another source or copy data from another source or whatever? And I like this question so much that I spent 5 years doing research on it, detecting the copying relationships between the structured data. And our basic idea, since I think we have time, so our basic idea is like this. If you have some multi-choice answer questions for the students, and then now you get 2 answer sheets, and they are exactly the same, and both of them have full score, will you say one must copy the other? Without any prior knowledge about whether they are good students or not so good students. You possibly wouldn't say one has to copy from the other because they can both be excellent students and give perfect answers. However, if you see 2 answer sheets exactly the same and they make a lot of common mistakes, at this point you would say, okay, why do you make so many common mistakes? So that's the intuition. And we use the intuition to find out copying relationship, and we will lower the vote for the copiers. Yeah. So, however, for this actually comes to this page, this slide. So for this copy detection, although we did so much work and we found that it works perfectly not perfectly, works very well for like thousands of data sources, we just cannot get it scaled to billions of data sources. It's just too many data sources when we need to have a complexity of O(n) squared. So that part is still left out for this work, but it is important. So I see you also have a question.
So, I mean, haven't said much about how you're extracting facts from natural language, which is hard enough, and presumably that's why most of your accurate facts come from the semi-structured stuff. But I guess how, could that be improved with better text parsing or?
So let me try to be really, I think, funding here. Are there any people here doing natural language processing? A lot, right? And do you think we are fully ready for extracting knowledge from the web, arbitrary web pages?
Well, I guess I work on Deep Dive, which is a...
Yes, you work on Deep Dive.
Yeah, so that's somewhere in between thinking NLP is very necessary or just a supporting tool. So somewhere in the middle. Maybe.
For Deep Dive, the interesting thing is, to my understanding, it is about the gene science domain, not the full web, right?
I think general applicability. I work on the gene stuff, but yeah. I mean, like at freebase level, comparing against freebase level, those things are I think we have decent extraction capabilities.
That's very nice. Yeah. So typically, like as I said, from our extractions, even from the same project, we found that the extractions on free text the quality is much lower than the extraction on semi-structured data. And we do have some NLP tools to do the annotation for web contents, and then we apply like distance supervision, etc., to learn the patterns, but it is still error prone. And one of the reasons of these errors is because we don't have enough negative examples.
Kind of a side question on this whole thing, but I noticed that if I plug in 3 keywords or 4 keywords on my computer, I get certain results. If I plug in the same exact keywords into somebody else's computer, I'll get different results. Is that because of previous history on the computer? Or?
So it is more of the personal search. So I assume you are talking about Google. I don't know if like Bing is doing similar things, but Google has this personal search, and it will look at your search history, look at your click-through history, and then it will decide, okay, when you talk about Apple, you mean the iPhone company. You are not talking about what to eat. Yeah. And maybe for like for people who plant apples, it is different.
So clearing my history all the time religiously probably affects what I search.
Yeah, it will.
Well, except maybe the history is stored on their end instead of your end.
Yeah.
Okay. Let's go back to the next slide.
Don't destroy you, destroy the recent past.
Okay, so we will move ahead. Yes?
If you have multiple user logins on a Mac or a PC, is this past history kept in the per user database, or is it more global?
It is per user and very likely per machine. So let me put it in this way: if you use the same, let's say, Gmail account, then it is per user. If you do not log in, it is more per machine.
And if somebody else logs in?
Yeah, that's true. It will basically attribute it to different accounts. Okay, so let's come back to trustworthiness instead of personal search. So we talked about the input readiness, and it's not that ready yet. And for the techniques, we already mentioned some of them, like the simple versus sophisticated facts about different perspectives about copy detection. And one thing I didn't mention that much in my graphical model is that we assume for each subject-predicate pair, there is a single truth, which is obviously not true. So like a person could author multiple books, and a movie star could play in multiple movies. And why do we use this single truth model? We do have a multi-truth model, but if we compare the results, the single truth model is so much better. And when we use multi-truth model, the precision dropped significantly. And this is also associated with the fact that we have a very bad extraction. So if we use the single truth model, yes, we miss some of the correct facts, but on the other hand, we filter the huge amount of noise. And another thing we don't capture is the value similarity. So for example, we have some gold standard, or what we decided to be correct, saying that somebody was born in Oakland. But on the other hand, we see a source saying somebody was born in San Francisco, and then we say this is incorrect. However, what this San Francisco might be just referring to the big, large San Francisco area. And another thing is, I think one of the questions mentioned about this is kind of a triple filtering. We found we cannot evaluate based on all of the extracted triples. Recall that I said we sampled 100 websites. For 15 of them, we are not confident that they are trustworthy. And actually, 2 of them, we extract triples irrelevant to the topic of the source. For example, for one of the web sources, it gives the business listings in Brazil. But all of our extracted triples says this city belongs to this state, this city has this zip code, this state belongs to Brazil, and so on. So it doesn't have anything regarding the business listing. And then just to say this is a trustworthy sources because of the geography information correctness, this is not fair. And we have 12 sources where we basically evaluate on the trivial triples. And trivial basically means something that is obviously true. And as an example, we have a source that provides hotel listings. And most of our extracted triples says what is the accommodation type of this hotel. And 95% of the types are hotel. And if you see, this is a hotel website where all we know is those hotels have accommodation type hotel. You really can't say this is a trustworthy source. So we need to do all of the things to filter the triples that are irrelevant, give lower weight to the trivial triples, etc. And finally, let's look at the output application readiness, the customer readiness. There are basically two usages of the trustworthiness score. The first one is to predict the quality for websites and web pages. And to use this, we have to combine this with some other signals like the page rank and the click-through rate. And currently, it is not super clear how to do the combination. And a second application is to recommend sources. If I want to collect knowledge about this vertical regarding food cheese variety, what are the data sources where I can get a lot of good, high accurate information? And here the interesting thing is we can consider those verticals or domains as head verticals and tail verticals. For head verticals like movie, like song, we know what are the good data sources. And for movie, let's say, I mean, you know you want to go to IMDb, and you don't need any recommendation for it. But for the long tails, we have some recommendations, but because of the sparsity of the extractions, we might miss some good sources. And here it actually comes to my sort of suggestion to the research community. And I think now if you look at the knowledge curation, knowledge extraction, knowledge management systems, they have done very good job, but it's more about the head entities and the head verticals. And however, if I have a company and I want to extract knowledge for a particular head vertical, what will I do? I will buy data from some authoritative sources, which everybody knows, and then I will hire 50 engineers to script the data for it. And then I have high quality data, and I can refresh the data from time to time, and I don't need to worry about the quality issue. But for the kind of the arbitrary extractions, as I mentioned, the quality can be quite low. On the other hand, this engineering approach, it does not scale to the tail entities, to the tail verticals, where we might have like millions of tail verticals, but we don't know what are the good sources, and we don't know where to get the good data. And so I'm hoping the research could really help for those body to tail data, for those long tails. And so here the call to arm thing is we want to leave no valuable data behind, including tail verticals, tail sources, tail entities, tail attributes, and also data from, let's say, a long time ago, kind of maybe out of date, but it would be valuable history data. So typically, I would end my talk with some Go links, and here I will end my talk with some not Go links. And for knowledge-based-trust.org and knowledge-based-trust.com, these are registered during the News Buzz week, and we have no control of it, and we wouldn't be responsible for lack of information there. And with this, I will end my talk. Thank you. So any question? Yes?
So did you just open a new field for search engine optimization and spam creation?
So yes, I think this can be considered as a new field to decide the trustworthiness, to decide the truthfulness.
You don't hire a search engine optimization company because you want to be more truthful. You hire it because you want more traffic.
However, I mean, if you get boosted with more trustworthy data, then, I mean, you will have more traffic.
Yeah, but just because you added more trustworthy data doesn't make you more trustworthy.
Why?
I insert 5,000 great facts just to slip the one untruth that I want you to have.
So that is a very good point, and this is actually one of the challenges I mentioned. We need to figure out, so first, we need to figure out what is the truthfulness of those information. If a lot of the information is basically saying the sky is blue, birds could fly, etc., and that shouldn't be given a lot of weight. And the second, smart people, they can put a lot of non-trivial correct information and then say, hey, this singer sings this song and this politician is from this country, blah, 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 blah. And then finally he says, oh, by the way, Obama is really from Kenya. And then we would be biased by the many correct facts. So that's something very interesting, and we are still considering how to solve that problem.
How do you handle conflict between authorities? The case in mind, the discovery of misfolded proteins, which was denigrated for a number of years until Stan Kirsner was able to prove it and got the Nobel Prize for it. But that sort of knowledge coming out and being denied.
So this actually is related to one of the research ideas which we call time machine. And for time machine, there are basically two things we want to discover. One is the evolving truth. And something is correct at some point. For example, using the simplest example, I'm working for Google now, and 5 years ago, I'm working for another company, and 10 years ago, I'm a graduate student from UW, something like this. So the truth is evolving over time. And the second thing is the sort of the belief of truth. So for example, at some point, people believe the sun is rotating around the earth, and it is certainly not true, but at some point, it is believed to be true. And I believe there should be a lot of research can be done on this. Yes?
What is the best way to validate authoritative sources?
So this is actually a very interesting question. What is the best way to validate the authoritative sources? And we found that because the majority of the data sources, they do not intentionally give bad information. And typically, if something is correct, then there will be more sources claiming it, or more authoritative sources claiming it. If an authoritative source is claiming something opposite to most of the other sources, then it is really a question mark of whether it is true or false. We might compute the probability not really 0, but 0.4, 0.5, but it's a question mark. It basically says, we are not sure if this is correct or not. Yeah.
I look at different leading edge science. And different leading edge science is usually one authoritative source, and everybody else is wrong. So you can't do it by quantity.
I agree. And that's why, so let's say if you are a good source and I'm a bad source, and let's say we are all about scientific things, and at some point I come up with a new discovery which unfortunately is wrong, but because I'm a bad source, and for that discovery, it will be given a low probability. And because you are a good source, and if you come up with some discovery, you will get much higher probability, although you conflict with the rest of the world. And you will have a higher probability to start with, and hopefully with more and more people agreeing with you, the probability will go up.
Decision.
How did you figure out he was a good guy to begin with?
How do you know that he's a good guy or a bad guy?
Oh, that's a very good question. So we
actually, the good guys, the bad guys have just flipped, right?
Yeah. So we have two ways. The first way is we start with assuming all of the sources have the same quality. And then recall that we iteratively compute these probabilities and quality until it converges or until a certain number of rounds. So this is a purely unsupervised way. And a second way is that we bootstrap the quality of a data source using some gold standard, for example, using the freebase with the local closed word assumption. Does this answer your question?
Well, no, I understand a little bit of how. I'm just not sure it's 100% correct. Maybe 99%, 98%, but maybe that's good enough.
Yeah, I mean, the only thing I could say is, I mean, there are definitely problems and there are definitely wrong decisions, but according to the results, this is what we get.
If you've done any work in like trying to characterize what are the sources of inaccurate information, like, that Obama was born in Kenya, clearly that's from, politically motivated sites, but, you mentioned gossip sites. I wonder, are there other broad categories or sources of inaccurate information you've discovered?
We haven't done so. It would be very interesting research.
Did you see the one recently where somebody discovered there was a school in India that was a sham, but they managed to infiltrate Wikipedia?
No, I don't.
Get the
local version of it. I'm on the Belgian royal family. Okay. So, how sensitive is it to your ranking function? Why don't you use, say, harmonic mean instead of arithmetic mean?
Maximum likelihood?
Or, yeah, there's a bunch of different...
So we actually started thinking about, we use the maximum likelihood, and that's basically the M step. That's a true M step. But then it turns out to be very complex. And there are some paper, I couldn't remember, so I remember the complexity is n to the power of 3. And then it wouldn't scale for the web scalability. And so that's why we...
It's too expensive for Google.
But harmonic mean...
Too expensive even for Google.
Harmonic mean should scale, though, just as well as arithmetic.
That's a good question. We haven't tried. Yeah.
There's a mean for everybody, so. Maybe there's a right mean that makes everything better.
Yes.
What are your expectations to where this is all headed? To what extent will this become anything near deterministic? In what kind of time frame? My impression is it's very interesting, but more as a philosophical discussion of what constitutes truth and how do you define a fact and how do you identify the way of determining if something is accurate or not, as opposed to a science or an engineering discipline where you write the code and you come up with an answer at the back end. Where do you think this is heading, and how quickly will you be getting to something that's solid?
First, let's talk about regarding solid or regarding, when this iteration would stop. So what we found is that because of the simplification in the M step, so we found that if we consider only the source accuracy, then it does not necessarily converge. And however, if the number of triples is far more than the number of sources, then our observation is that it typically converges. But for this particular experiment, we didn't really go until it converges because that's just too expensive. And we stopped after 5 rounds, and we found that after 5 rounds, the results are pretty much stable. And actually, starting from the 3rd round, the results are pretty much stable. And then for your question about where it leads to, do you basically mean what I just said, or do you mean where the research results will lead to?
It's currently in a research phase and you're learning as you go. At some point, this might actually roll out and become part of a standard product and a main part of the Google a replacement for page ranking or a strong supplement? What kind of time frame before you think it gets to that level of reliability?
So this is something I couldn't answer, but there are indeed, I mean, many collaborations where we are trying to use this to decide whether extractions are correct. We are trying to recommend web sources for verticals. We are even trying to find out what is the quality of a website, etc. Yeah. Yes?
When do you think I can type in 27 symptoms and get a better diagnosis than a doctor?
So Google now launched some a medical knowledge panel, and basically it will say for some disease what are the symptoms, and you can basically search disease by symptom or symptom by disease. I don't know how mature it is and what is the coverage by for this. What I heard is this is definitely not something that they get from sources. They hire doctors to come up with this.
Which doctors do you hire?
It's supposed to hire a lot of top doctors and a lot.
By the way, just a quick comment on maximum likelihood typically converges in distribution. Doesn't converge onto a number if you go through a loop. You don't converge on numbers, you get distributions. So the point is you may have to report the distribution. And I think that would be more interesting to say these sources say that yes, these say no, or whatever. Let me report the distribution like you do with some of the other real-time news, whatever, how many papers, blah, blah, blah.
Yes, yeah.
So
That's a very good point.
the science can tell you often things converge in distribution, but not single numbers. Politics the other way around.
Smoking.
And I mean, yeah, I mean, if you consider those, especially because we sort of make this simple single truth assumption for every data item, subject, predicate pair, and for the objects, I mean, for each object, we compute some probability, and that's kind of a distribution for the probabilities of the candidate objects. Certainly, it is not true that distribution for each object, for each triple.
That's why